This question tells us that the line given intersects a surface and asks us to determine the points of intersection. Fortunately, we don't have to understand exactly what this surface looks like, but what we can do is figure out the parametric equation of this line and sub in those parametric expressions in the appropriate places for x, y, and z in the surface. And then we'll be able to solve for what the parameter equals at the points of intersection, and it'll be pretty straightforward from there to determine the points themselves. So what we do is try to determine what is the vector equation of the line in question, and then from there get the parametric equations. So we can see that the line in question will go through the point 3, 5, 0, and have a direction vector of -1, 3, 1. Imagine a denominator of 1 there. So we have our x expression 3 minus t, our y expression 5 plus 3t, and our z expression 0 plus t. And so what we then get from there is a pretty straightforward procedure. We want to substitute each of these expressions into the equation of the surface. Subbing in 3 minus t for x, 5 plus 3t for y, and t for z in both places gives us this long quadratic equation. And from there we're able to solve it and determine that t is 3/2 or t is 3. And once we know the values of t that satisfy the condition of intersecting with the surface, we can simply find out the values of the points. We get an x-coordinate of 3/2, y is 19/2, and z is 3/2 at one of the points. And at the other point, the one where t is equal to 3, we get an x-coordinate of 0, a y-coordinate of 14, and a z-coordinate of 3. And so we've got 2 points of intersection.